By the end of this, we will be able to use and identify stem and leaf plots, dot plots, histograms, bar charts or graphs, and box and whisker plots, which are also called box plots. Alright, who's taller? In a sample of 14-year-olds from the United Kingdom, where the height is given in centimeters, they separated this data into males versus females. A way you could model this data is if you look at just the males. Our lowest value is 151, and our highest value is in the 180s. There it is, 187. So we go in between 151 and 187. Instead of writing 151, 154, 159, and all that, a stem and leaf plot will use the first one will signify 150s, the second one 160s, 170s, whoop, do not need that 0 there, and then 180s. So instead of writing 151, I'm just going to put a 1 there. For 154, I just need to put a 4 here. 157, a 7 goes here, and then 159, a 9 goes there. So I actually got rid of all my 150 data. There we go. And next I will go on to the 160s. So I'll look at the lowest 160s. It's 162, so I just put a 2. And notice I have two 165s. I have to put a 5 twice. 67, 169. We go to the 170s, I got 174, 175, 176, and 177. And I have 3 values in the 180. I got 180, 183, and 187. I could do the same thing for females here, but the female range is going to be a little different. The lowest female one is 151. And the highest female, is 152, and the highest female is going to be 169. So actually, I only need 2 there. And then what I could start to do is I could start to just plug in the numbers. 152, 53, 53. I got 3 girls at 158, so I'm just going to put some 8s there, up right there, and then 1 girl at 159, and then I'm just going to look at the 160s now. I got a bunch of 160s. 161, 63, 63, 64, 65, 65, and this becomes my stem and leaf plot. Notice none of the data gets lost here. It's just constructed in a different way. If you wanted to, you could have combined the two males and females. And the way this would look is for males, the lowest one was 151, and then 154, it would just go a little backwards. Females was 152, we also had a 7 and a 9 there. For males in the 160, we had a 2, we had a 163, 65, 65, 7, and then a 9. And what we could actually end up doing is we could end up constructing all of this table. And it means the same things, it just saves a tad bit of time. So those are stem and leaf plots. Let's look at the same data, who's taller, males and females, and let's look at a dot plot. My blue dot will represent the males. So if you take a look at the first value, 154, I plop a dot down there. 157, 187, now I got two 165, so I'm going to put another dot above it. And then 183 and 180. And then what I could do is go ahead and plot the females. 160, 169. So I'm actually going to go above. And this is actually called a dot plot. We've seen this before. It's important to remember what each dot represents. And each dot represents one individual's height. From the sample. Histograms will look like bar charts, but there's a little bit of a difference. Histograms display quantitative data. So like this PPG is, for you basketball players, points per game. Because you could score 94, 96, you could score points in this range. You could score in between. So histograms actually display quantitative data. And here's another one. Percent of foreign-born residents and in the number of states. And notice this percentage down here, that is a quantitative. Bar charts are a little different. They display categorical data. And bar charts have little gaps in here. If you take a look, I got a gap here because this data is not continuous. And this was the radio station problem, if you remember that. Here's another example of a bar chart. Finally, box and whisker plots. These are pretty awesome because they include a 5-number summary. And that is, oh, I got a little bit of a mistake there. That is a minimum, Q1, medium, Q3, and maximum. This was the same data from the UK problem, the heights. And if we take a look at this right here is our minimum. This over here is our maximum. This edge of the box will be Q3. This edge of the box will be Q1. And in the center we will have our median. And the minimum is just the minimum value there. And if we pooled all the data, that was 151. Our maximum, we had a boy of 187 centimeters. And then I will give you the values here because we will learn how to do that on the calculator. So what you need to know about the box and whisker. Q1 means quartile 1. And if you think of quarters, they're worth 25 cents. So that means 25% of the data falls right here, in between the minimum and Q1. In between Q3 and the maximum, we'll think about having 3 quarters. So that's 75% to 100. So 25% of the data falls in between Q3 and the maximum. Finally, this box part contains 50% of the data where we have 25% of the data in between Q1 and the median, and 25% of the data in between the median and Q3. And that is a 5-number summary. The things I'm highlighting right there: the minimum, the Q1, the median, Q3, and the maximum. And here was just the female heights in centimeters, and notice I have it labeled here. So if you just take a look at this quickly, 25% of my data is here, another 25% in between Q1 and the median, 25% of my data is in between median and Q3, and another 25% is in between Q3 and the maximum. And that should be it.